This is Mrs. O'Neill for your Chapter 4 review questions and problems. So first, let's look at this picture. It looks like we have a solution of KBr. So again, on the molecular level, what would that look like? And it looks like we're going to put it in this new flask and mix it with NaCl. And again, if we look on that molecular level, really what's going on with NaCl. So we have potassium bromide in ions, and we have sodium chloride or salt in ions. Now remember, the KBr is also considered a salt. Remember, any ionic compound is a strong electrolyte, also known as a salt. And if we mix the two together, I don't know about you, but this looks like they all stay ions. So that means there's no precipitation that occurs. There's no reaction that's going to happen. So, so your bromides, most of them are soluble in solution, and your chlorides are soluble in solution. So when you mix the two together, again, you just get a bundle of ions. So you're going to go through this video by pausing when you see the question or the problem. Some of them have multiple parts. You can answer them mentally or on paper. I suggest having your calculator and your reference sheets out as well. You're going to continue playing the video to see your answers or possibly a game plan and or solution. And again, some of these are going to be above and beyond what you see on the test in class, but will help you with your AP exam. So here we have number 1, your redox reactions. Now, at a first glance, what I would see is your first two reactions here. I see oxygen by itself as a reactant, so your oxidation number is going to be 0. And on the right-hand side, I see oxygen in compounds as products. So no matter what, the first two reactions are going to be redox. So you might want to go through and actually assign each individual element your oxidation numbers, just to check your answers with mine. But if I look at the third equation, on a first glance, I would look at that and go, oh, since nitrogen, oxygen, and hydrogen are in compounds as reactants and compounds as products, it might not be a redox. However, going above and beyond, when I look at nitrogen, I go, nitrogen is a nonmetal, and nonmetals tend to have multiple charges. They can contain a +1, a +2, a +3. They have multiple charges. So does the charge of nitrogen change from that reactant NO2 to the products? And the answer is yes. So pause the video and make sure you understand where I got all of the oxidation numbers. Hopefully you can pick out which element is being oxidized and which element is being reduced. And on the third reaction here, if you notice that nitrogen gets oxidized in one compound and then it also gets reduced in another compound. And that's called disproportionation, and that is spelled correctly, but that does happen. You have one element as a reactant, but the products, one gets oxidized and one gets reduced. So number 2, your KBr. So here we have 2 samples of KBr, 2 different volumes and 2 different molarities, and you have a new volume, a new total volume. So now what's going to be the molarity of that KBr final solution? So again, here's our game plan. You need to pause and read this over, and hopefully that makes a little bit more sense if you're not quite understanding how to do it yet. So the big key here is you need to divide by that total new volume when you do the mixture. So then here is your answer, and hopefully that makes sense now. Okay, number 3, titration. And I don't know about you, but when I hear titration, I think, this might be a stoichiometry problem. And I've highlighted your acids and your bases, hopefully to make it a little bit more understandable. So let's work out this net ionic equation. The first thing you need to do is always label your strong and your weak. So the first substance here, since it's not on your list, is going to be a weak acid. The second, NaOH, is on your list, so that's going to be a strong base. The third thing here, ooh, it's a metal with a polyatomic ion, so that is a salt or an ionic compound, so that's going to be strong. And if you notice here, H2O is in the form of a liquid. So just as a reminder, anything weak stays together all the way through. Anything strong breaks apart into its positive and negative ions. And of course, your liquids also stay as is all the way through. So if you have a net ionic equation, you continue to play to find the answer or pause. And now can you come up with a net ionic equation? Hopefully you came up with this, and you do need the aqueous, you do need the liquid, you do need the coefficients, correct coefficients, and you also need the correct charges. So now your second part, again, to me, it's like a stoichiometry problem. So now that I have a net ionic equation, I can put in my information above or below the substance in my reaction. And now I can basically use stoichiometry to get from one to another. Now, the only difference here is you do have to like equals. You know how I sometimes say a stoichiometry problem, you just keep going with your conversions. But here I would have stopped at the moles, and then I would have divided by the liters they gave me and continued the problem. So again, pause, and hopefully this dimensional analysis setup makes sense. Titration number 2. Hopefully you paused and tried those out, and here's your answer to A. Answer to B. And can you do the net ionic equation for this? So I believe it just asked for the equation, but now can you give me the net ionic? So pause and come up with that. So again, first things first, I see a strong base. I see a strong acid. I shouldn't have to go any further. Ladies and gentlemen, when you see a strong base and a strong acid, automatically in your head should be water. You're making water. So it doesn't matter which way. And since I see 2s for your coefficients for all of them, those can also go away as well. But strong acid, strong base, boom, you've made water. And your answer to C, again, another stoichiometry. Here I even write out a little bit of the plan as to what you're doing. So again, pause and make sure that your answer matches mine as well as the setup. Because on your AP exam, sometimes they do give you points for the setup as well as the answer. Number 5, stoichiometry. So hopefully you paused and got your answer of A. And can you do the net ionic equation again? Again, just more practice here for you. So you should have gotten that as your net ionic. Again, you need exactly the way it looks like. You need your substance, you need the type of substance, your solid, your aqueous, your liquids, you need your correct coefficients, and you need charges when they are supposed to be there. Your answer to B here. Your answer to C. All right, good luck on the test.